All right, guys, I know some of you had a little bit of trouble with the match my parabola activity, and we only started talking about function transformations in class, so I'm going to go through the practice problems from the notes, and hopefully that will help you as you complete the homework tonight, also based on function transformations. And obviously, if you have questions and you want to meet tomorrow, we can talk about it at school. All right, so in example, or in level one here, this is just you writing the equation of g of x in terms of f of x. So let's say I don't even know the equation of f of x. I just know that this thing is f of x. And in each case, the solid function is f of x. And I want to figure out the equation of this dotted function g of x. Well, in the first example, it looks like all I need to do is take f of x, move it to the right by 7 from negative 4 over to 3. So right by 7. All right. So I'm going to say g of x is f of x, but it's if I moved it to the right 7, then it's going to be f of x minus 7, right? Because remember, the way that we move things left to right is by subtracting or adding inside the function in the opposite sign of the direction we want to go. Now, I know that this actually has an equation, so you could say that this is the parabola x plus 4 squared plus 1, and that is the original equation of f of x. But we were told to give the equation in terms of just f of x, so I don't really need the original equation here. I'm just going to write it with f of x representing all of that. And then I'm going to bring this down so that the vertex is now at negative 5. So it's gone from 1 to negative 5, so minus 6. And that's all we're doing for this exercise. What do I need to do to f of x to have it become the dotted function g of x? Okay, so for 2, g of x is... Well, one thing that definitely needs to happen is this thing needs to flip. So negative f of something. Do I need to horizontally shift it? It doesn't look like it. I can just bring it straight up. So negative f of x. That's my start. Now, if that's all that I did, it would look like this. Right? So I obviously need to shift it up by 4. But if I shift it up by 4, it's not going to quite line up because f of x is much more narrow than g of x. So the question becomes, how more narrow? How much more narrow is it? And that's going to affect our a value. So if we zoom in here and have a look at what's going on, I'm going to look at this like it's the bottom of my function. And I'm going to be thinking about where this point is, because on this parabola, if this were just the x squared parabola that we started with, that point, which is 3 units away from the vertex, would be 9 above the bottom of the parabola. But it's only 3 above. So that means that what used to go to a height of 9 only goes to a height of 3. So all of these points are a third of the height that they normally would be. And that's why I know that my a value here has to be a third. So ultimately, my equation is going to look like this. Zooming makes it look a little goofy, but negative 1/3 f of x plus 4. Now what I did there, you could just go through the normal process of finding a point that you know, looking for a like we've done in the past, but we also have some patterns that we've picked up on with parabolas that hopefully help us find that a value a little easier. All right, now this one. You could do this one with a horizontal shift and then a vertical shift, but I am noticing that both of the vertices sit on 6 and negative 6 for x values, so I could do a reflection here. Let's do that, because there are other options, but I want to practice using some of these ideas that we talked about. So I'm going to take my f of x function, and I'm going to reflect it. And now it's over here. Now all I have to do is shift it down, because this does appear to just be an x squared parabola with no a value change. So I have to move it down from a vertex of 2 to a vertex of -3, so I'm going to bring it down by 5 units. So that's that initial exercise, which is just understanding what you're doing to a function without the actual equation itself. We're just using function notation and rewriting g of x in terms of f of x. Now for 4 and 5 and 6, we're actually going to give the equation. So what happens if I take f of x, this thing here, and shift it to the left by 4 units? Well, that's going to mean I need to add 4, because remember, horizontal shifts go the opposite direction of the sign. So it's going to look like this if that's all I do. -2 times x plus 7. There we go. All right. What if I then reflect it over the x-axis? Well, if I reflect it over the x-axis, I have to negate it all. So negate everything. If I negate everything, that's now 2 times x plus 7 squared plus 9. Remember, everything got negated. And then a vertical shift down 2 units. I'm going to have to take 2 away from this 9. So f of x is now 2 times x plus 7 squared plus 7. All right, for example 5, first we're going to bring it down 3 units. So f of x is now 1/4 x minus 1 squared plus 5. I got to bring it down 3 units. And then a vertical reflection over the vertex. The reason this is different from the last one is if you reflect over the x-axis, you have to negate everything, the whole function. If you're just reflecting over the vertex, then we're only going to negate this part. We're going to leave this part alone. And I know that's not something that we talked about in class, but most of the time when we do our reflections, we're going to try to do the reflection over the whole x-axis so that we avoid this confusion. But I wanted to make this point here that this is what happens if you only negate the first part. So this would be f of x equals -1/4 x minus 1 squared, but still plus 5. So all we've reflected over then is the vertex, not the whole x-axis. And then we're going to reflect over the y-axis, and for that, we do just negate the x. So -x minus 1 squared plus 5. All right, and 6. A vertical stretch by a factor of 6. So that means I need to multiply this whole thing by 6. If you multiply 2/3 by 6, you're going to get -4 here. So f of x equals -4 times x minus 7 squared minus 2. Then a horizontal shift to the left, so I'm going to need to add 4. -4 x minus 3 squared. And then a reflection over the y-axis. -4 x minus 3 squared minus 2. Okay. And those are sort of the most straightforward version of these. Take an equation, do these certain things to it until you end up with a new equation. All right, and then finally we're actually going to do this with graphing. So we're going to graph y equals x squared, one piece at a time, until it becomes this function. So the first piece, I want to sort of treat it like PEMDAS. I want to do one thing at a time, starting with the interior of the function. So the first thing I'm going to do is deal with just y equals x minus 6 squared. So what's that going to look like? Well, that's your parabola, but it's been moved 6 units to the right. Okay. The next move, if we step one step outside of that, is this 3. Y equals 3 times x minus 6 squared. Well, that's going to be a vertical stretch by a factor of 3. So all of these points are going to be 3 times as far from the x-axis as they used to be. So this used to be 1 above the x-axis. Now it's 3 above the x-axis. This next point used to be 4 above the x-axis. Now it's 12 above the x-axis. So that's off the graph, but I'll include it up here. So we just stretch the parabola out, and now that I'm negating it, that's going to reflect this whole thing over the x-axis. So now it looks like this. And then finally, I've got this plus 5 to deal with. So y equals negative 3, x minus 6 squared plus 5. I'm going to take this whole thing and I'm going to shift it up 1, 2, 3, 4, 5. And then those 2 points. That one might be too far over. I think that should be here. Yeah, okay. Anyway, get the idea. All right, hopefully that helps explain some of those transformations in a little greater detail and help with tonight's homework.